next we are going to work on our transformations, and it's not really on a graph here, it's just written algebraically. It says describe the transformation of the graph of the parent quadratic function y equals x squared. Then identify the vertex. There are actually 4 different transformations going on right here. The negative is its own transformation, and then multiplying by this 1/2, that's its own transformation. This +4 does a transformation, and the +1 does a transformation. The negative itself is a reflection. This is going to be a vertical reflection. The negative is not on the x. It's not going to go horizontally like x's do. It's going to be like a y. It's going to be a vertical reflection. So there's one of my 4. Then the next step is the 1/2. Multiplying by half, taking half of something, it makes it smaller. This is a vertical shrink. The +4, any addition or subtraction is a shift of some kind. Because it's x plus 4, it's going to go horizontally like x's do. This will actually shift to the left by 4. And then the +1, that's not next to the x, that's going to go like y values do, up and down. So this will shift up by 1. Okay, so there's all of our transformations. Then identify the vertex. Okay, the reflection and the shrink, those don't affect the vertex. It is the translation shifting. Usually your vertex is at 0, 0 on the parent function. So these shifts went left 4, up 1. So left 1, 2, 3, 4, up 1. Our new vertex is at -4, 1. Next up, it says let f of x equal 2x squared minus 3. Write a rule for a new function g that horizontally shrinks the function by 2, shifts f up by 1, and reflects f over the y-axis, and then identify the vertex. So again, we've got multiple things going on here. It says, first thing, horizontally shrinks by 2. Just a reminder, horizontally means like x's go horizontally. And in fact, I need to do 1/2, 1/2 is going to go next to the x, which was squared, so the 1/2 is also squared. If you are going to shift up by 1 next to your -3, you're going to have a +1 to shift it up 1. And then it reflects over the y-axis. Here's my y-axis right here. So if I reflect to the other side of my y-axis, it actually changed the sign on my x values. So I'm going to have to put a -1/2 right there. And we still have 2 right here, hasn't gone away. We still have that. So here is our new function, g of x. There is a bit simplifying we can do here. So the g of x function, I'll get 2 times -1/2 x squared, and then if I combine these, I get a -2. There's probably a little more simplifying you can even do from here, but this is your g of x function. Then it says to identify the vertex. Mainly the shifts, the translations have to do with the vertex. A reflection or a stretch or shrink, those don't really have much to do with the vertex. The vertex, though, it looks like we had to shift up 1. So usually the vertex is at 0, 0, but we shifted up 1. So vertex is 0, 1. And then last one's here. Write a function for each of the graphs below. I can tell what the parent function is based off the graph. This first one, it looks like a parabola, so my parent function has to be y equals x squared. And then let's look at what transformations happen. My parent function usually looks like this. So we've got a few things going on. I can tell that it was shifted up 1 and to the right by 3, where the vertex is. Also, I see it's got a vertical reflection. Instead of facing up, it's actually facing down, so vertical reflection. And let's see if there are any dilations. Usually this goes like up 1 over 1. Up 4 over 2, that kind of thing. This is not going 1 and 1. It actually, when I go over 1, it only goes down by 1/2. When I go over 2, it actually goes down by 2. So I think it kind of took 1/2 of my y values. So that would mean y values are vertical. I would say a vertical shrink by 1/2. All right, so on our parent function, the x squared, we are going to do everything that is horizontal in the parentheses with the x, because x's go horizontally. So moving to the right, that's horizontally. So I will make a -3 in with the x to shift everything to the right by 3. Everything else has to do with vertical. It has to do with y values. So those are not going to go in the parentheses with the x. To shift up 1, I'm going to have a +1 outside of the parentheses. The vertical reflection has to be a negative, so that negative is outside of the parentheses. And again, a vertical shrink by 1/2. So that 1/2 has to be multiplied outside of the parentheses. So here is our function. You can write y equals, you can put g of x equals, f of x equals, but there is our function with all of those transformations. Next up, we've got an absolute value function. That is my parent function. So absolute value of x, and let's see what's going on with that. This was also facing down, so there had to have been some vertical reflection. And then the parent function usually hits at 0, 0, and then it goes up 1 over 1, up 1 over 1. This vertex is not 0, 0, so let's look at the shifts. The vertex itself went up 1, 2, 3, 4, and to the left by 1. Okay, so I'm going to say that it was shifted up 4, and it was shifted to the left by 1. Okay, so there's all of our shifts. We've got the reflection. Let's look at if there's a dilation or not, a stretch or shrink. The parent function that I drew right here, it looks like it's a little wider. The green one here looks like it's a little skinnier, so I may have done a dilation. Again, usually this goes over 1, up 1, over 1, up 1. This one, though, looks like as I go over 1, it's going up 3, or I suppose down 3, but then I go 2 and, oh, it goes by 6. Okay, so I think we had a vertical stretch by 3. It's like they took the ends of this and like pulled those up and stretched it out, made it a bit skinnier. To write our function, we are going to do anything that's horizontally has to go in the absolute value with the x. X's go horizontally. Moving to the left, that's horizontally. That would have to have a +1 to shift it all to the left by 1. And then everything else is vertical, like up and down. So everything else would be outside of the absolute value of x. A vertical reflection, you got the negative for the reflection. To shift it up 4, we've got to have a +4 outside of the absolute value there. And a vertical stretch by 3 means I need that 3 multiplied by my absolute value. Okay, and again, you can write y equals, f of x equals, g of x equals, but here is our new function with all of those transformations.